What if I told you that space is not silent? We've been taught our whole lives that space is a vacuum, that sound cannot travel, that beyond our atmosphere there is only nothing. But that's not entirely true. NASA's most advanced instruments, deep space telescopes, plasma wave detectors, electromagnetic sensors, have been capturing something extraordinary for decades. Vibrations, frequencies, waves moving through plasma, magnetic fields and cosmic gas clouds. And when scientists convert these signals into audio, we can actually hear. The results are deeply, profoundly terrifying. Today, you are going to hear the real, actual sounds of our solar system. The sun, the moon, every single planet. And from the frozen edge of our solar system, the eerie signals captured near Pluto. Buckle up, turn off the lights, and turn your volume all the way up, because space has a voice, and it wants to be heard. Every single day, you look up at the sky and see it, a bright, warm, comforting ball of light. The sun, the heart of our solar system, the source of all life on Earth. But what if you could actually hear it? The sun is not the gentle, peaceful star it appears to be from 93 million miles away. It is a violent, churning nuclear inferno, a sphere of superheated plasma 109 times wider than Earth, constantly erupting, boiling and exploding. On its surface, solar flares erupt with the energy of 1 billion nuclear bombs. Plasma rivers hotter than anything on Earth churn and crash. Magnetic field lines snap and reconnect in massive explosions called coronal mass ejections, hurling billions of tons of charged particles into space at millions of miles per hour. And all of this makes sound. NASA's Solar Dynamics Observatory has been recording the sun's oscillations for years, pressure waves bouncing through its interior like sound waves through a massive drum. Scientists call this field helioseismology, literally the study of earthquakes on the sun. When those vibrations are sped up and converted into audio, doesn't that sound like something alive? Something ancient and angry and impossibly large. That deep, resonant drone, that haunting, breathing roar, is the actual voice of the star that gives us life. It pulses, it shifts, it groans like a creature stirring in its sleep. Scientists have found that the sun actually sings, producing millions of individual tones simultaneously, like a choir made of nuclear fire. But there's nothing comforting about this song. If you were somehow transported close enough to hear it without any protection, if that sound could travel through the vacuum of space at full strength, it would be louder than any sound ever produced in human history. A wall of noise, an overwhelming, obliterating roar. The sun isn't just burning up there in the sky, it's screaming. If the sun is a roaring monster, then Mercury is its closest victim. Mercury is the smallest planet in our solar system and the closest to the sun. It has almost no atmosphere, no moons, no magnetic field strong enough to protect it. It is a barren, cratered, scorched rock, battered relentlessly by solar winds and radiation for over 4 billion years. During the day, temperatures on Mercury reach 430 degrees Celsius, hot enough to melt lead. At night, they plunge to minus 180 degrees Celsius. No other planet in our solar system experiences temperature swings that extreme. And yet, Mercury makes a sound. NASA's Messenger spacecraft, which orbited Mercury for 4 years, detected plasma waves and charged particle interactions around the planet. These electromagnetic signals, when converted into audio, produce something deeply unsettling. Do you hear that? That thin, metallic shriek. That hollow, whistling whine cutting through the silence like a blade. It sounds like a ghost, like something that was once alive and isn't anymore. And in a way, that's exactly what Mercury is. Scientists believe Mercury may once have had a more active geology, volcanic activity, a stronger magnetic field, perhaps even conditions that were slightly less hostile than they are today. But the sun slowly stripped it bare, blasted away its atmosphere, cooked its surface, left behind nothing but a dead, silent, radiation-soaked rock, screaming faintly into the void. That sound is Mercury's dying cry, the whisper of a world the sun is slowly consuming. It is one of the loneliest sounds in the solar system. If Mercury is unsettling, Venus is something else entirely. Venus is often called Earth's twin. It's almost exactly the same size, similar mass, similar distance from the asteroid belt. From far away, it looks almost familiar, but Venus is anything but. Venus is the hottest planet in our entire solar system, even hotter than Mercury, despite being twice as far from the Sun. Its surface temperature is a constant 465 degrees Celsius, day and night, pole to pole, without variation. The reason? A runaway greenhouse effect so extreme that it makes Earth's climate concerns look minor by comparison. Its atmosphere is a crushing, poisonous nightmare, 92 times denser than Earth's, the equivalent of being 900 meters underwater, made almost entirely of carbon dioxide, with clouds of sulfuric acid swirling at 350 kilometers per hour. It rains sulfuric acid on Venus. The rain evaporates before it hits the ground because the surface is too hot. Even the rain doesn't survive. The European Space Agency's Venus Express mission and NASA's Magellan spacecraft both detected electromagnetic signals from Venus, plasma waves interacting with what remains of its weak magnetic field. When converted to audio, these signals produce something that sounds like it belongs in a horror film. That slow, grinding, churning moan, that deep, oppressive drone that seems to press down on you from all sides. That is the sound of an atmosphere 92 times heavier than ours. The sound of sulfuric acid clouds rotating endlessly. The sound of a world that could have been Earth, that perhaps was Earth-like billions of years ago, but instead became a vision of absolute hell. Some scientists call Venus a warning, a preview of what Earth could become if we're not careful, a planet-sized cautionary tale. When you hear that sound, that slow, suffocating groan, it's hard to disagree. Venus doesn't just sound terrifying, it sounds like a warning. Now here's where it gets personal. You live on Earth, you breathe its air, you walk on its surface. You probably think you know this planet pretty well, but Earth has sounds you've never heard. Sounds that have been humming around you your entire life, invisible, inaudible, yet utterly real. Earth has a magnetosphere, a massive magnetic field generated by its molten iron core that extends thousands of miles into space. This field is what protects us from the solar wind. Without it, the sun would strip away our atmosphere just like it stripped Mercury's. Life as we know it would not exist. But the magnetosphere doesn't just sit there quietly doing its job. It sings. When charged particles from the sun slam into Earth's magnetic field, they create electromagnetic waves called chorus waves, because when scientists first converted them to audio, they sounded eerily like birds chirping at dawn. But listen more closely, because there's something in that sound that goes beyond birds, something ancient, something alien. That rising, falling, swirling chorus of tones that sound like thousands of voices all speaking at once in a language just beyond understanding. That is Earth, our home planet, singing to the universe every single second of every single day, and we never even knew it. But here's the part that really gets under your skin. These chorus waves aren't just beautiful, they're dangerous. Scientists have discovered that these very same waves can actually accelerate electrons in Earth's radiation belts to nearly the speed of light, creating what researchers call killer electrons. Particles so energized they can penetrate satellites, damage spacecraft electronics, and even pose a radiation risk to astronauts. The song of our own planet is weaponizing particles in space. Earth doesn't just have a voice, it has a weapon, and it's been firing it into space, silently, invisibly, for billions of years. Close your eyes for a moment. Imagine standing on a vast, rust-coloured desert. The sky above you is not blue, it's a dusty, pale orange. The air is so thin you'd be dead in seconds without a suit. The temperature hovers around -60°C. Dust devils spiral silently across the cracked, dry ground. You are on Mars, and it is profoundly, devastatingly quiet. Or so we thought. In 2021, NASA's Perseverance rover did something no spacecraft had ever done before. It deployed a microphone directly onto the Martian surface and actually recorded real sound on another planet for the first time in human history. What it captured was both fascinating and haunting. Mars has an atmosphere, thin, made mostly of carbon dioxide, about 1% as dense as Earth's, and sound does travel through it. But it travels differently than it does on Earth. Lower frequencies travel normally, but higher frequencies, sounds above roughly 240 Hz, slow down and fade faster. What this means is that if you were standing on Mars and someone was speaking to you from just a few meters away, their voice would sound muffled, delayed, wrong. Like hearing someone talk through a wall that keeps getting thicker. And then there's the wind. That low, sweeping, hollow moan. That cold, empty whistle cutting across an ancient landscape. That sound of wind moving over a world that once had oceans, that once may have had life, and now has neither. Scientists believe Mars was once remarkably similar to early Earth. It had liquid water, a thicker atmosphere, perhaps even rivers, lakes, and seas. There is growing evidence that microbial life may have existed there billions of years ago, before Mars lost its magnetic field, before the solar wind stripped away its atmosphere, before the water froze and evaporated and disappeared. What you're hearing in that Martian wind is the sound of a world that lost everything. A planet that could have been alive and chose death instead. Or rather, had death chosen for it. If you listen carefully enough to that Martian wind, it almost sounds like something grieving. Something that remembers what it used to be and can't let go. That is the sound of Mars, and it is one of the saddest things you will ever hear. Everything changes when we reach Jupiter. We've left the rocky inner planets behind, we've crossed the asteroid belt, and now we arrive at the king of the solar system, a planet so massive that 1,300 Earths could fit inside it. A world with storms larger than entire continents that have been raging for hundreds of years. Jupiter is not a gentle giant, it is a swirling, violent electromagnetic powerhouse. Its magnetic field is 20,000 times stronger than Earth's. It generates the most intense radiation belts in the solar system, so powerful that they would be lethal to an unprotected human within minutes and would fry unshielded spacecraft electronics in hours. The Voyager 1 spacecraft discovered something extraordinary when it flew past Jupiter in 1979. As it approached the planet, its instruments began picking up radio emissions, electromagnetic waves generated by Jupiter's insane magnetic field, interacting with its moons and the solar wind. When scientists converted these signals to audio, what they heard stopped them cold. That overwhelming, churning, layered roar, those deep, rhythmic pulses beneath a surface of crackling static and rising tones, that sound of something massive rotating, a planet 11 times wider than Earth, spinning faster than any other planet in the solar system, completing a full rotation every 9 hours and 56 minutes. Jupiter doesn't just sound big, it sounds alive. It sounds like the heartbeat of something ancient and powerful beyond comprehension, like the breathing of a creature so enormous it makes the sun look small. Some of the sounds Jupiter produces are called whistlers, electromagnetic pulses generated by lightning in its atmosphere. Jupiter has lightning storms unlike anything on Earth. Individual lightning bolts on Jupiter are estimated to be 1,000 times more powerful than any lightning strike ever recorded on our planet. And that lightning is constant, unending, flashing somewhere in Jupiter's atmosphere every single second of every single day. The roar you hear in Jupiter's sound is partly the electromagnetic signature of billions upon billions of those lightning strikes, all happening simultaneously across a storm system larger than Earth itself. If Jupiter had a voice, it would shake the solar system, and listening to that recording, it does. We need to talk about Saturn. Of all the sounds captured from space, all the planets, all the moons, all the electromagnetic signals ever recorded by human instruments, nothing compares to what NASA's Cassini spacecraft recorded as it approached Saturn. Nothing. Saturn is the 6th planet from the Sun. It is famous for its stunning ring system, billions of chunks of ice and rock orbiting the planet in a disk so wide it would almost stretch from Earth to the Moon. From a telescope, Saturn looks almost too perfect, too beautiful, like something out of a painting. But what Cassini detected as it entered Saturn's magnetic field shattered that peaceful image forever. Saturn produces radio emissions called Saturn kilometric radiation, electromagnetic waves generated by interactions between its magnetic field and its rings, its moons, and the solar wind. These emissions shift and change. They rise and fall. They pulse and swirl in ways that seem almost deliberate. Let that sink in for a moment. That eerie, shifting, otherworldly wall of sound. Those rising and falling tones that seem to almost form patterns. Those pulses that feel rhythmic, almost like a heartbeat, or a breath, or a signal. When people hear Saturn sound for the first time, the most common reaction is not fascination. It is fear. Because it doesn't sound like a planet. It doesn't sound like a natural phenomenon. It sounds like something communicating, like a transmission from somewhere, or something that is not from here. Scientists have found that Saturn's radio emissions are directly tied to its auroras, massive light shows at its poles similar to Earth's northern lights, but on a planetary scale. The emissions shift with the rotation of those auroras, creating rhythmic patterns that repeat like clockwork. But knowing the scientific explanation doesn't make it less terrifying. Because when you close your eyes and listen to that sound, that slow, rising alien chorus, your brain doesn't hear physics, it hears intention. And that is the most frightening thing of all. Most people forget about Uranus. It's the 7th planet from the Sun. No stunning rings like Saturn, no legendary storm like Jupiter, no romantic mythology like Venus. It sits quietly in the outer solar system, pale blue-green, distant, seemingly unremarkable. But Uranus is hiding something deeply strange. First, the basics. Uranus is an ice giant. Beneath its pale atmosphere lies a crushing ocean of water, ammonia, and methane, compressed under pressures so extreme that scientists believe diamonds literally rain down through its interior, sinking slowly toward a diamond ocean at its core. It rains diamonds on Uranus. Let that sink in. But the strangest thing about Uranus isn't its diamond rain. It's its rotation. Uranus is tilted on its side, rotating at a 98-degree angle relative to its orbit around the Sun. Scientists believe it was knocked sideways billions of years ago by a collision with a protoplanet roughly the size of Earth. The impact was so catastrophic, it permanently tipped the entire planet over. So Uranus rolls around the Sun like a bowling ball. Its poles face the Sun directly for decades at a time. Its seasons last 21 Earth years each. And when Voyager 2 flew past in 1986, the only spacecraft to ever visit Uranus, its instruments detected something extraordinary. Electromagnetic signals pulsing from the planet's bizarre, lopsided magnetic field. That steady, rhythmic, pulsing hum. That electronic throbbing that sounds almost mechanical, almost engineered. Like something deep inside the planet is beating, counting, measuring. Unlike any other planet in the solar system, Uranus's magnetic field is not aligned with its rotation axis. It's tilted at 60 degrees and offset from the planet's center, meaning it wobbles and shifts in ways that no other planetary magnetic field does. The result is electromagnetic emissions that pulse in strange, irregular rhythms that scientists still don't fully understand. That sound is Uranus talking to the universe in a language we haven't decoded yet, and somehow, that's more unsettling than anything else we've heard so far. And then there is Neptune, the eighth and final planet, the most distant world in our solar system, a place so far from the Sun that sunlight takes 4 hours to reach it, a world where the Sun appears not as a warm, bright disk in the sky, but as little more than a bright star. Cold, distant, unhelpful. Neptune is a world of extremes. It has the fastest winds ever recorded on any planet in the solar system, raging at up to 2,100 kilometers per hour. Winds so fast they're supersonic. Winds that would tear apart any structure ever built by human hands in a fraction of a second. Its largest moon, Triton, orbits backwards, moving in the opposite direction of Neptune's rotation, which tells scientists it was captured from the Kuiper Belt billions of years ago, rather than forming alongside the planet. And Triton is slowly spiraling inward. In roughly 3.6 billion years, it will get close enough that Neptune's gravity will tear it apart, creating a brand new ring system around the planet. Neptune is already planning its future, and it doesn't care that we're here to witness it. Voyager 2 captured electromagnetic signals from Neptune during its 1989 flyby, the only close encounter humanity has ever had with this distant, violent world. Do you hear that? That howling, roaring wall of sound. That shrieking, overwhelming rush. Like standing at the edge of a cliff in a hurricane that never, ever stops. That is Neptune, screaming at the edge of our solar system. A world of violent beauty and terrifying power, sitting in the cold dark at the very boundary of everything we call home. Of all the planets, Neptune sounds the most angry, the most raw, the most primal. It sounds like a planet that does not want to be found. And for most of human history, it wasn't. Neptune was only discovered in 1846, and we've only visited it once, with one spacecraft, for a few precious hours. We barely know it, and already, it terrifies us. Pluto is no longer classified as a planet. In 2006, the International Astronomical Union officially reclassified it as a dwarf planet, a decision that broke millions of hearts and sparked debates that continue to this day. But whatever you call it, planet, dwarf planet, Kuiper Belt object, Pluto is real. It is out there, billions of miles away in the frozen darkness beyond Neptune, and it has a voice. NASA's New Horizons spacecraft made its historic flyby of Pluto in July 2015, the first time humanity had ever seen this distant world up close. What it revealed was breathtaking. A heart-shaped plain of nitrogen ice, mountain ranges of water ice rising 3 kilometers high, a surprisingly complex atmosphere of nitrogen and methane. Pluto was not the dead, featureless rock scientists expected. It was a living, dynamic, surprisingly beautiful world. And New Horizons detected something else too. Plasma wave emissions, electromagnetic signals generated by the interaction between Pluto's thin atmosphere and the solar wind streaming past it at the very edge of the solar system. Listen to that carefully. That faint, lonely, delicate signal. That soft, wavering tone rising and falling in the dark. So quiet compared to Jupiter's roar or Neptune's howl. So small, so far away. Pluto sound is perhaps the most emotionally affecting of all the planetary recordings, because it doesn't sound powerful. It doesn't sound dangerous. It sounds alone. It sounds like a small world sitting in the cold and the dark at the very edge of everything, sending out a faint signal that asks a single, heartbreaking question. Is anyone out there? In the 3 billion miles between Pluto and the Sun, that signal travels outward, into the void, into the interstellar darkness beyond our solar system, into a universe so vast and so empty that the signal will travel for billions of years without ever finding an answer. Pluto's sound doesn't terrify you the way Jupiter does, or Saturn does. It does something worse. It makes you feel small. The Moon, our nearest neighbour, the most familiar object in the night sky, something humans have stared at, written poetry about, and worshipped for thousands of years, and something that made Apollo astronauts hear sounds they were not supposed to talk about. In 1969, as the Apollo 10 mission swung around the far side of the Moon, the side permanently facing away from Earth, completely out of radio contact with mission control, astronauts Eugene Cernan, John Young, and Thomas Stafford heard something through their headsets that stopped them cold. Music. Strange, eerie, outer space music. Their own words, drifting through their communications system. Whistling, swirling tones with no obvious source. For approximately 1 hour, as they passed through the silence of the Moon's far side, completely alone, completely cut off from Earth, the music played. The recordings were classified by NASA, locked away, not released to the public for decades. When they were finally declassified and released in 2016, the audio caused a worldwide sensation. Scientists believe the sounds were caused by interference between the VHF radio systems of the command module and the lunar module. A perfectly rational, perfectly scientific explanation. But the astronauts who were there, trained, experienced, highly rational men, were genuinely unsettled. Cernan himself said years later that the sound was unlike anything he could explain, that something about it felt wrong, felt intentional. The Moon has no atmosphere, no magnetic field to speak of, no known mechanism for generating electromagnetic signals the way the other planets do. And yet, it made music for 3 astronauts alone on the far side, in the silence and the dark, 240,000 miles from home. Some things don't need a scientific explanation to be terrifying. They just need to be heard. 5 seconds of silence. 10 seconds. Because after everything you've heard tonight, the screaming sun, the dying cry of Mercury, the hellish groan of Venus, Earth's weaponized chorus, the sadness of Mars, Jupiter's thundering heartbeat, Saturn's alien transmission, the mystery of Uranus, Neptune's rage, Pluto's loneliness, the Moon's classified music. you need a moment to understand what all of it means. Here is the truth that these sounds reveal. Space is not silent. Space has never been silent. Every planet, every star, every moon, every magnetic field, every cloud of cosmic gas, all of it is generating waves, vibrations, frequencies, signals that ripple outward in every direction, forever at the speed of light. The universe is not empty. The universe is full of voices, and here is the question that keeps scientists awake at night. If our tiny little solar system, 8 planets, a handful of moons and dwarf planets, generates this much sound, this much electromagnetic noise, this many signals, what is the rest of the universe saying? We have identified approximately 2 trillion galaxies in the observable universe, each galaxy containing hundreds of billions of stars, each star potentially surrounded by planets, each planet potentially generating its own electromagnetic signature, its own plasma waves, its own cosmic voice. 2 trillion galaxies, each one screaming into the void, and we can barely hear our own sun. We are standing in the middle of the loudest concert in the history of existence, and we are deaf to almost all of it. On August 15, 1977, astronomer Jerry Ehman was analysing radio telescope data at the Big Ear Observatory in Ohio. He was part of SETI, the search for extraterrestrial intelligence. His job was to scan radio frequencies from deep space, looking for anything unusual. He found something unusual, a radio signal so powerful, so perfectly structured, so unlike anything generated by known natural phenomena, that Ehman circled it on his printout and wrote a single word in the margin: wow. The signal, now known simply as the wow signal, lasted exactly 72 seconds. It came from the direction of the constellation Sagittarius. It was broadcast on a frequency of 1,420 MHz, the exact frequency that scientists had theorized an intelligent civilization might use to contact others, because it is the natural emission frequency of hydrogen, the most common element in the universe. It was never detected again. In 47 years of searching, with increasingly powerful instruments pointed in every direction, scanning every frequency, never again. No one has ever fully explained the wow signal. Natural explanations have been proposed and largely dismissed. It remains the strongest candidate for a signal of extraterrestrial intelligent origin ever detected by humanity. We heard something, once, for 72 seconds, and then it was gone. Was it a message? A beacon? A random transmission from a civilization that has no idea we exist? Or something else entirely? Something our science isn't yet equipped to understand? We don't know. We may never know. But consider this. If the universe is full of voices, if every planet and sun and moon is broadcasting electromagnetic signals in every direction, then perhaps the universe is not just making noise. Perhaps it is speaking. Perhaps those sounds you heard tonight, Saturn's rhythmic transmission, Jupiter's thundering pulse, are not just physics, not just electromagnetic phenomena, not just pressure waves in plasma. Perhaps they are part of a conversation so vast, so ancient, so far beyond our comprehension that we are only now, in this tiny, fragile, extraordinary moment of human history, beginning to develop the instruments to listen. We built radio telescopes. We sent probes to every planet. We launched spacecraft beyond the edge of the solar system. We pointed microphones at Mars and recorded the wind on another world for the first time. We are learning to listen. And the universe, patient, ancient, indifferent, and impossibly vast, has been waiting for us to do exactly that. Go outside tonight. Look up at the sky. Find a star, any star, and hold your gaze on it for a moment. That star is generating sound right now. Electromagnetic waves are rippling outward from it in every direction at the speed of light. Plasma waves are crashing through its interior. Magnetic fields are twisting and snapping and releasing bursts of energy into the void. That star is alive with sound, and it is utterly, completely, perfectly silent to you. Because between you and that star lies the vacuum of space. Hundreds of trillions of miles of nothing through which no sound wave can ever travel. All of that noise, all of those voices, all of that cosmic screaming and singing and pulsing and groaning, stopped at the edge of our atmosphere, converted by extraordinary human ingenuity into the recordings you heard tonight. For one brief, remarkable moment, you heard the universe speak. You heard the sun's nuclear roar. You heard Saturn's alien transmission and Pluto's lonely cry. You heard things no human ear was ever designed to hear. And now, as the silence settles back in, as the cosmos returns to its apparent stillness above your head, ask yourself one final question. In a universe this loud, this vast, this ancient, this full of voices, is anything out there listening back? If this video terrified you, or amazed you, or made you feel something you can't quite name, then the universe did its job. Subscribe, because we're just getting started, and space has a lot more to say.